Hello student, I am Anand Sonone from SNJ Junior College, Sangwad. Today we learn about math first. First after that is the mathematical logic, in which exercise 1.4. We solve some examples on the concepts of negation of conditional, negation of biconditional, negation of negation, negation of disjunction and negation of the conjunction statement. In exercise 1.4, the example number first is using the rules of negation, write the negation of the following with justification. The first example is negation of the cube implies P. Write the negation of these compound statement. Okay, therefore मग इथे आता negation of the q implies p दिलेला आहे म्हणजे मला negation of the conditional statement यूज करावा लागेल. The rules of the negation of the conditional statement, that is the negation of in bracket p implies q equivalence to p conjunction negation of the q. Therefore here the solution is for the first example, that is the negation of the q implies p is here solution is negation of a q implies p is negation of in bracket negation of a q implies p equivalence to in this law negation of the in bracket p implies q is equals to p conjunction negation of the q. Here the negation q is p is replaced by here negation q and q is replaced by the p. Therefore this becomes, therefore the negation of in bracket negation q implies p is negation of the q conjunction negation of or which is also equivalent to negation of the p conjunction negation of a q using the law of commutative by law of commutative and which is also equivalent to using the rule of the negation of disjunction, negation of in bracket p disjunction q equivalence to negation of the p conjunction negation of the q. Here negation of the p conjunction negation of q which is equivalent to negation of in bracket p disjunction q by law of determinants. Okay, that is the first example. Second example, that is the p disjunction negation of the right negation. Therefore solution is p disjunction negation q चं काय लिहायचं आपल्याला negation लिहायचं. It is very easy. Therefore let negation of in bracket p disjunction negation of a q. Therefore negation of p disjunction negation q equivalence to कसलं negation घ्यायचं आपल्याला disjunction. Disjunction चं negation आपल्याला माहिती negation of the in bracket p disjunction q is equals to negation of the p conjunction negation of the q. Therefore it becomes negation of the p conjunction negation of a negation q. Therefore which is equivalent to negation of the p conjunction negation of the negation itself q here. Therefore by law of negation of negation. That is the result. Negation of the in bracket p disjunction negation q equivalent to negation of the p conjunction q. That is the answer. Again solve here some examples. The example number third, that is P implies in bracket P disjunction negation of the Q. Okay, write down its negation. Therefore, it is also an easy. Therefore, write the negation of P implies in bracket P disjunction negation of the Q. Okay, that is the implication. Therefore, again use the rule of the negation of the implication is negation of in bracket P implies Q is equals to P conjunction negation of the Q. Therefore, negation of in bracket P implies P disjunction negation of the Q, which is equivalent using this definition or rule number 4. That is here P conjunction negation of P disjunction negation of Q using by result number. Therefore, which is also equivalent to P conjunction in bracket. आपण use शकतो की again use the rule of negation of disjunction, that is the negation of the P conjunction negation of the negation Q by rule number second rule number. Therefore, it becomes again at P conjunction in bracket negation of the P conjunction negation of the negation Q itself Q using the by result number. That is the negation of the negation. Therefore, negation of in bracket P implies in bracket P disjunction negation of the Q equivalent to P conjunction in bracket negation of the P conjunction Q. That is the answer. Again, take one more example. That is the example is in bracket P disjunction negation of the Q implies P conjunction negation of the okay. Therefore, here implication of first bracket implies second bracket, like its negation. Again, use the rule number 4. Negation of the implication is P conjunction negation of the Q. Therefore, write down here. Write down here negation of in bracket negation of P disjunction negation of the Q implies P conjunction negation of the Q. Therefore, negation of in bracket the first bracket P disjunction negation of the Q implies P in bracket P conjunction negation of the Q. Therefore, which is equivalent to P disjunction negation of the Q as it is conjunction negation of in bracket P conjunction negation of the Q using the fourth rule, that is the law of implication or law of condition, law of negation of conditional state. Okay. Therefore, which is also equivalent to P disjunction negation of the Q conjunction negation of this bracket, it becomes negation of P disjunction negation of negation Q using the first law by law of negation of conjunction okay. Therefore, which is equivalent to first bracket P disjunction negation of the Q as it is conjunction in bracket negation of the P disjunction negation of negation Q itself Q by law of negation of negation. Okay, that is the answer of this negation of this state. And some examples again and solve at home. of the same type. Okay. The example number second in the exercise 1.4 is rewrite example number second. Rewrite the following statements. The following statements without using if then. The first is, the example is if 2 is a rational number, then 2 is a rational number, then root 2 is an irrational Rewrite the following statements without using if then. These if then phrase used in the conditional statement, and we know that one more result in the conditional statement, or by definition of the conditional statement is, see here, P implies Q equivalent to, which is equivalence to negation of the P disjunction, negation of the P disjunction Q, that is the result. Therefore, here is the statement is, compound statement is, if 2 is a rational number, then root 2 is an irrational number. This compound statement rewrite without using here the if then. Therefore, using this result, P, if P implies Q equivalence to negation of the P disjunction Q. Therefore, firstly, these result write in the symbolic form. Therefore, the solution is, consider here, or let P is 2 is a rational number. 2 is a rational number, and Q is root 2 is an irrational number. Okay. Therefore, the symbolic form is rho P implies Q. Symbolic form is P implies Q. Okay. Therefore, we know that P implies Q equivalence to negation of the P disjunction Q. Therefore, rewrite this sentence without using the if then. Therefore, P is 2 is a rational number. Negation of the P is 2 is not a rational number. Disjunction, that means or Q that is the root 2 is an irrational number. These compound statement without using here the if then sentence, and that is the answer of given example. Okay. Another example, they solve at the home. Therefore, the example is if f of 2 equal to 0, then f of x is divisible by x minus 2, divisible by x minus, okay. These example rewrite without using the if, okay. Next thing, that is the example number 3. Example number 3. Without using truth table, without using truth table, prove that P, if and only if Q equivalence to P conjunction Q, bracket complete, disjunction in bracket negation of the P conjunction negation of Q. Okay. The example number 3 in 1.4, that is without using the truth table. Without using truth table aside, solve these examples using the laws of logic. Don't use here the truth table. Okay. Therefore, all of you know that the law of idempotent, law of commutative, law of associative, law of De Morgan's, law of complement, law of identity, law of conditional statement, law of biconditional statement. Okay. Therefore, here the LHS, that is P if and only if Q equivalence to prove that the LHS is in bracket P conjunction Q, bracket complete, disjunction in bracket negation of the P conjunction negation of the Q. Okay. Therefore, solution is P implies Q equivalence to what to prove that the RHS. Therefore, here therefore we know that the definition of biconditional statement. Definition of the biconditional statement: P implies Q and Q implies P equivalence to P conjunction. P implies Q and Q implies. Therefore, this becomes P implies Q, and that is the conjunction Q implies. That is the first result by concepts of conditional, किंवा आपण म्हणू शकतो by conditional law. Okay. Therefore, which is equivalence? आता आपल्याला कशात द्यायचंय? कंजंक्शन आणि डिस्जंक्शन मध्ये, कंजंक्शन डिस्जंक्शन मध्ये आलं पाहिजे. ओके. Therefore, P implies Q, conjunction of Q implies P. Therefore, we know that the biconditional law is P implies Q equivalence to negation of the P disjunction Q. That is the biconditional law. Therefore, using this result, negation of P implies Q is negation of the P disjunction Q conjunction. Q implies P, that is the negation of the Q disjunction P. Okay, by conditional law. Therefore, which is equivalence to? आता इथे आपण जर बघितलं तर negation of the P disjunction Q आहे. इथे पण disjunction, इथे पण disjunction, इथे conjunction. ओके. मग आता लॉ ऑफ डिस्ट्रीब्युटिव्ह यूज करू शकतो का आपण? दोघांमध्ये काही कॉमन निघेल का? तर दोघांमध्ये इथे निगेशन P तर P आहे, इथे Q आहे, इथे निगेशन Q आहे. मग आपण काय करूया? कन्सिडर दिस इज ॲज द one single simple statement, and that is second, that is the negation of the Q disjunction P. Therefore, this bracket distributive these. Okay, therefore by using the distributive law. Okay. Therefore, see here in bracket negation of the P disjunction Q distribute this bracket. Therefore, in bracket negation of the P disjunction Q conjunction negation of the Q bracket complete disjunction in another bracket negation of P disjunction Q conjunction here by law of distributive, by law of distributive. Okay, therefore which is equivalence to, therefore which is equivalence to, again use here the law of distributive. Therefore this conjunction negation Q distribute this bracket. Therefore in bracket negation of the P conjunction negation of the Q disjunction Q conjunction negation of the Q. Okay, by using the, again use here the law of distributive. Same thing is here, disjunction in bracket negation of the P, this bracket distribute the conjunction P. Therefore negation of the P conjunction P bracket complete this disjunction Q conjunction P in another bracket. Again use here the by law of distributive. Law of distributive. Therefore, see which is equivalence to, which is equivalence to bracket complete negation of the P conjunction negation of Q as it is disjunction Q conjunction negation of the Q आहे आणि त्याचं निगेशन आहे, दोघांचं काय असेल कंजंक्शन. ओके, therefore using here the Q आणि त्याचा कॉम्प्लिमेंट दिसतोय, कंजंक्शन असेल तर इट इज फॉल्स. therefore negation of the P conjunction negation of the Q disjunction Q conjunction negation of the Q using the law of the complement it is false. Disjunction in bracket disjunction in bracket negation of the P conjunction P, same thing is here, that is again and false. Disjunction Q conjunction P by law of complement, by law of therefore which is equivalence to, see here in bracket negation of the P conjunction negation of the Q bracket complete disjunction false. Therefore there is here again use here the law of the identity. True आणि false असेल तर आपण law of identity म्हणतो. therefore this becomes it becomes in bracket negation of the P conjunction negation of the Q by using the law of identity. P disjunction जर false असेल तर आपण घेतो P. Okay, therefore P disjunction false equivalence to P. therefore negation of the P conjunction negation of the Q bracket complete disjunction false, that is the negation of the P conjunction negation of the Q. Same thing is here, bracket complete disjunction false, disjunction in bracket Q conjunction P is Q conjunction P by law of identity. Law of identity. Okay, therefore which is equivalence to, which is equivalence to, we have to prove that P conjunction Q. therefore again use here the law of commutative. bracket मध्ये पण commutative घेऊया आणि out of bracket पण घेऊया. therefore P conjunction Q disjunction negation of the P conjunction negation of Q by law of commutative, by law of commutative. therefore P equivalent Q equivalence to P conjunction Q disjunction in bracket negation of the P conjunction negation of the Q, which is without using truth table, which is okay. Right like this. Second example, that is the example number second. In bracket P disjunction Q conjunction in another bracket P disjunction negation of the Q word so that equivalence to P. Therefore solution is P disjunction Q conjunction P disjunction negation of the Q equivalent to C word so that is the P. आता P आपल्याला प्रूव्ह करायचा आहे म्हणजे सगळ्या टर्म्स काय झाल्या पाहिजे Q हा disjunction negation of the conjunction disjunction negation of the Q सर्व काय झाले पाहिजे इलिमिनेट झाले पाहिजे. मग ऑब्झर्व हियर these two brackets here P disjunction P and this disjunction here also P and disjunction is common. ब्रॅकेट मध्ये disjunction आहे आउट ऑफ ब्रॅकेट these two bracket joined by the connective conjunction आहे. मग आपण काय यूज करू शकतो लॉ ऑफ द डिस्ट्रीब्यूटिव्ह. आता इथे डिस्ट्रीब्यूट झालाय काय डिस्ट्रीब्यूट झालाय P disjunction. मग आपण मी काय करतोय P disjunction काय करून टाकतोय कॉमन घेतोय म्हणजे कॉमन घेतोय therefore this becomes P disjunction. डिस्ट्रीब्यूटिव्ह लॉ यूज करतोय therefore P disjunction मी जर बाहेर घेतलाय तर इन ब्रॅकेट काय आहे बघा इथे राहतोय Q conjunction आणि काय राहतंय negation of the Q म्हणजे Q conjunction काय असणार आहे ते negation of the Q. Okay, by distributive law. By distributive law. By distributive law. Okay. Therefore, which is equivalence to P disjunction Q conjunction negation of the Q. Q आहे आणि त्याचा कॉम्प्लिमेंट आहे. Therefore, using the complement law, Q आणि कंजंक्शन Q असेल कॉम्प्लिमेंट त्याचा असेल आणि कंजंक्शन जर निगेशन Q असेल आणि कंजंक्शन जर दिलेलं असेल तर it becomes false by law of complement. Okay, therefore which is equivalent to P disjunction जर false असेल तर by law of identity it becomes E. Okay, and which is the RHS which is true. That is the second example. Okay, and solve some remaining examples. Okay, thank you. This exercise 1.4 complete here.